right, hi everyone, welcome. I will start with brief introduction. I'm Anna Lyushchenko. I'm a web development expert, passionate about quality software on Ukraine. I'm Google developer expert in Flutter and Dart. And I'm also Women Tech Makers ambassador. I have 8 years of experience in creating cross-platform mobile applications with Xamarin and then Flutter. And currently I work as a senior staff mobile engineer at a company called Tide. You can always find my recent work with this social media handle. As the talk title promises, we will have some fun with code generation. And fun indeed is a geeky word when applied to software engineering tools, but also it's an acronym. A very well thought in advanced acronym, as you see. So, significantly reduced implementation with code generation. The goal of this talk is to show how using such tools can speed up the development process by helping you deliver more while writing less code. There are in fact different kinds of code generation tools available in the toolbox of a Flutter developer. It can be one-time generation with Mason template. It can be various command line tools. Today we're going to focus on Build Runner in particular. Actually, today we're going to have a very practical session where I will show the usage of all these code generating packages in a small Flutter application. They will help us solve the following tasks: data models, JSON serialization, REST API implementation, navigation, assets management, dependency injection, localization, and tests. These are all pretty typical tasks to solve when developing even a small Flutter application. And that's a lot to cover, so let's dive right into it. The application I'm going to develop today is a news app. When just opened, it shows a list of recent articles about space flights. Users can tap on the list item and see the article details, image, a link to read the text on the source website, and some details. Also, some articles are dedicated to a space flight that was mentioned in several news. They are marked with the link icon. When the link button is tapped on the article details page, it opens a list of articles related to the same space mission. As a data source, I will use the Spaceflight News API from the Space Devs. Let's now check the code. Okay, this is the first version of the application that doesn't use code generation at all. We can check the path-spec YAML to see the list of current dependencies. These are DO for performing network requests, Flutter block for state management, Flutter localizations, and Intel for localizing the app, Gedit for dependency injection, URL launcher to read articles on web, and Flutter lints, which comes with the Flutter project template. So as you see, there is no usage of Build Runner so far. To be honest, I'm so used to using code generation on a daily basis that I somewhat suffered when preparing this manual implementation first, just to show you the difference later. I will now first give a high-level overview of the code, and we will look into some areas in more details when we are factoring them to use code generation. Let's look at the articles list page first. It has an optional launch ID parameter. When the app is opened, this parameter is null. But when this page is opened from article details to display a list of related articles, this launch ID has some value. It has block provider and resolves articles list block from the container, passing a launch ID as a parameter to the block. This DI container here is just a pretty name for the Gedit instance. Let's now check the block. Articles list block extends a block with this type of event and state. As you see, for now they implemented with plain Dart inheritance. The block receives few dependencies with constructor injection and also has a launch ID which is passed to the parameter from the page. The Spaceflight News API here is a class responsible for performing requests to the Space News API. It has getArticles method that returns a list of article models, which is a plain Dart object. Back to articles list block. It also has a navigator dependency, which is an abstraction over the innate navigation mechanism with domain-specific methods go to articles list and go to article details. The actual navigation is implemented inside the Spaceflight News router, which receives navigator key on which it performs named navigation. When the articles page is opened, it loads the list of articles from the API, updating block state first to loading and then to content or error. And when user taps on the list item, it calls the go to article details method of the navigator, which we just saw. For this DI container, to know how to create the articles list block with all its dependencies, a preliminary setup was required. This init.di method here does all the registrations of all the classes that we plan to resolve from the getIt instance later. Here, for instance, is the articles list block registration. As for article details page, it is very similar to articles list. It accepts article ID as parameter. It has block, results from DI container. The block also has API and navigator as dependencies to load article details when the page is shown and to navigate to a list of related articles when user taps on the corresponding button. These two features come together in the application widget. The navigator key, which is registered as singleton in getIt, is provided to the Material App widget and is also used in Spaceflight News router, which implements the onGenerateRoute method. And the last bit to check is localization. It is tricky to implement the localization mechanism as it supports placeholders and plurals without using code generation, because even the official Flutter guide uses one. So here I have a custom delegate that uses either English or Ukrainian translations depending on the current device settings. I prepared a set of commits for today. Each of them adds a new dependency and refactors one implementation detail of the app to use code generation. We will now walk through them one by one, and we're starting with data models. Let's take a closer look at the article model. It's a plain Dart class that declares a list of fields and a constructor where they are initialized. It also has a manual implementation of JSON deserialization. It overrides equals, hashcode, and lastly it has a handy copy with method that allows creating new article instances with only a few fields modified. There are a few things here that could have been better. For example, if I add a new field to the article model, all these methods here require updating. And it's easy to forget to update one, even if the field is required. Equals and hashcode methods have to be overridden, so two articles objects with the same field values will be considered equal. Otherwise, only two references pointing to the same article object would be considered equal. And this implementation was generated for me by Android Studio. And as you see here, for example, lists are still being compared by reference and not by the content. The toString method, which is not written here, would return an instance of article without mentioning exact field values. And finally, this typical implementation of copy-with doesn't allow updating nullable fields to null. And let's now also check the block state and event. For now, they implemented with plain Dart inheritance. When the block subscribes to events, there is no nice way to ensure it handles all event subtypes. We can and should write tests, of course, but it would be nice to be notified earlier, the very moment a new event is added to the hierarchy by getting compilation error. The same applies to the block state. There is no easy way to ensure all block states are represented in the UI. That's why we're going to use Freest package by Rémi Bousselet for both article models and block states and events. We now have a few new dependencies. First of all, the build runner. Build runner is a special package that doesn't do anything on its own, but provides a mechanism for other code-generating packages like Freest to create new files and put a valid Dart code in them. Here we have Freest package as dev dependency and Freest annotation as a direct dependency. Let's now check how the article model implementation changed. Much shorter, isn't it? The entire class is annotated with Freest attribute. It has a factory constructor that declares the same list of properties as before. And it also declares a part.freest.dart file, where all the additional code was generated. I already have this generated file next to current one, but that's because I have committed all the generated files in Git. Let me delete it. In real life, when you first declare such a model, and this file doesn't yet exist, you get compilation errors. There is a special command that starts code generation process. Flutter pub run build runner build lead conflicting outputs. Once it completes, the Freest file will reappear, and I won't have compilation errors anymore. There is also a variation of this command, where build is replaced with watch. This one will continuously watch for the file system changes and regenerate files if needed. I typically run code generation in watch mode when developing, but today I will not run this command anymore to avoid the delays. Instead, I added all generated files to Git. So the article class implementation became significantly smaller. And the cool thing is that it didn't lose a bit of the implementation which was written manually before. The generated class has the same list of fields. It overrides toString method that now includes field values. The reading equals method now performs a deep comparison of fields. And the generated copy-with implementation allows replacing nullable fields values with nulls, because method parameters have a default value of Freest object. Now let's also check blocks event and state. What you see here is an example of Freest union. The class hierarchy basically remains the same. The article list event-based class has 3 children: load, retry, and open details. In addition to all the methods like toString and copy-with we saw previously, Freest has also generated pretty useful methods for pattern matching. The usage of this map method ensures there are compilation errors if not all event subtypes are handled by block. And the same applies to the state. It is also refactored to be a freest union, while the previous class hierarchy is preserved. Here, the same map method is used. It ensures that all state subtypes have a corresponding widget displayed. Freest package has more capabilities like providing default values to fields, return the lists by default, more pattern matching methods, and others. Check out the docs on pub.dev. Next, I'm going to talk about JSON serialization. As I mentioned, the article model manual implements the deserialization logic. This is yet another area for improvement with code generation. For that, I'm going to use JSON serializable package by Kevin Moore from Google. I now have it as a new dev dependency, and JSON annotation as direct dependency. Back to article model. Now from JSON implementation changed from manual to just calling a generated method in a new file. Again, this part, generated file, contains the implementation, which is very similar to what I had previously. But the cool thing is that now it's not me who writes all this boilerplate code. I also have a new file named build.yaml here. It is a place to provide additional setup for code generating packages. For instance, here I configure JSON serializable package to consequentially call to JSON on all inner method fields and lists. And I also ask it to exclude null values when serializing to JSON. These settings apply to all models across this package. The generate for settings allows to control where the code generating mechanism will look for the source files. Limiting the path to only specific folders speeds up the code generation and also enforces developers to follow a particular package structure when organizing the project. This is especially valuable when working with large teams. The JSON serializable package exposes many more configuration points where you can control the code it generates. Check out the docs to learn more. Next, I'm going to refactor the Spacelight News API, which performs GET requests to SpaceDesk API with Dio. As you see here, not only I had to specify the path, parameters, and return type, but also needed to call Dio fetch and JSON deserialization over and over again. To optimize this implementation with code generation, I am going to use Retrofit package by Trevor Wong. Again, a new dependency in PubSpec file, retrofit among direct dependencies, and retrofit generator in dev dependencies. A new version of Spacelight News API still injects Dio and base URL in the constructor, and still has the same three methods. But I didn't have to implement those methods myself. All I had to do is specify the request path, parameters, and return type. Thanks to this REST API attribute, the method implementations were generated into this part file. The generated code is slightly extended version of the code I had previously, but in the nutshell it does exactly the same, performs request to the REST API through the Dio instance and parses the response data with the from.json method that was generated for us previously by JSON serializable. Retrofit package also offers a lot of other attributes to customize the request implementation it generates, including post, delete, and other for specifying request method types, supports query parameters and headers, etc. Check out the docs to learn more. Next, we are going to talk about navigation. Let me first remind you about the current implementation. The application uses name navigation. A navigator forms the navigation path URL using query parameter for launch ID and pass segment for article ID. The router class is responsible for providing the initial URL, which leads to the articles list without a parameter, and for converting the path and parameters to the actual strongly typed route. Instead of having this onGenerateRoute method implemented manually, I will use AutoRoute library by Milad Akiri. We again have two new dependencies, AutoRoute and AutoRoute generator. The navigator implementation didn't change. It still forms the same string path as it did before, but the router has changed completely. It is now annotated with AutoRouter attribute, listing the routes the app supports. It specifies articles list page as the initial page that responds to the articles path, and the article details page that has article ID as path part. The article ID in the details page is now annotated with path param attribute, and the launch ID inside articles list page is now annotated with query param attribute. The behavior of application navigation didn't change. It still responds to the named navigation, and these parameters get automatically parsed from path by AutoRoute generated implementation. I wanted to show that AutoRoute has generated strongly typed routes that replicates page parameters if it wants to use the non-named navigation. The application widget now contains a way of connecting the navigation to the generated AutoRoute implementation. The AutoRoute package supports many more features like nested and tabbed navigation, declarative navigation, and route guards. Check the docs on the pub.dev as usual. Alright, we are halfway through. So far, we have looked at data models and unions with Freest, JSON deserialization with JSON serializable, REST API requests with retrofit, and navigation with AutoRoute. The next task will be a simple one, just to give us all a small break. The article details page here, and the articles list page here use some images, and by default image resources are referenced by name, by file path, and it's easy to make a mistake there. And also renaming an image file may be a painful experience. I have extracted those paths to a standalone class to facilitate the renaming. Still, as you understand, maintaining this class requires some manual work and attention. That is why I'm going to delegate this task to a code-generating package called FlutterGen by Daichi Furia. I have a new dev dependency, FlutterGen Runner. It has generated a new file, listing all the images I have in the assets folder. If I had some fonts, it would also list them here. I have updated the UI to use these new classes. Now if I name the image file and rerun the code generation, these field names would also be renamed, and I will get compilation errors in places I need to update, which is much more secure than looking for a string. FlutterGen supports PNG and SVG images, Rive animations, fonts, and also has a few configuration points. Check out the docs on pub.dev to learn more. Next, I would like to talk about dependency injection. Remember this file here. In order to use getIt, I had to teach it first how to create all the classes in my project annually, calling register factory and register lazy singleton methods. Also, as you see here, I am declaring an environment enum and providing different base URLs for test environment. Then I pick the desired environment when calling this initDI from the main method. This allows me to have different entry points with different base URLs, should I need to create multiple application points to different backends. So to help me generate all this stuff, I will use injectable package by Milad Akeri. New dependencies are injectable and injectable generator. Look at how the initializer file changed. All the code I was writing previously manually is now generated to this file. In order for this to happen, I still had to teach the injectable how to register dependencies in getIt. But this mechanism is much more neat. First of all, I had to annotate this initDI method with injectable init attribute. Let's take a look at the block. It is now annotated with injectable attribute. It means each time someone will resolve an article details block from getIt, a new instance will be created. It is beneficial because each time we open article details page for a different article. The article ID parameter is annotated with factory param attribute, which means whenever someone resolves article details block, they have to pass article IDs parameter. Another example is Spaceflight News API. It also has injectable attribute. It doesn't have any state, so it's not harmful to create a new instance each time. Retrofit required us to create this factory constructor. However, by default, injectable is looking for default class constructor to register in getIt. For such cases, injectable suggests using this factory method attribute. It can be applied to the named or factory constructor or a static creation method to be used instead of the default constructor. Most parameters of this class are also interesting. Here we inject the DO instance. But the good question is how getIt will know how to create such instance. We cannot simply annotate it with injectable attribute because we don't own the source code. Base URL is also interesting. It's just a string, not a unique custom type. And we might want to register a couple of strings, for example, base URL and API key. To distinguish between the same types, getIt and injectable provide a way of naming instances. That is why this base URL is annotated with named attribute. Base URL is a string. Similar to DO, it is a type we don't own, and thus cannot just annotate it with the injectable attribute. So let's now see how both DO and base URL are registered in getIt to be delivered to Spaceflight News API. For third-party dependencies, injectable offers a modules mechanism. As you see, it is a class annotated with module attribute, and the dependencies we would like to register are declared as its methods and getters. DO is annotated with lazy singleton, which means only one instance of DO will be created, and only when it is first requested. There are two instances of base URL here. First of all, as you see, they are both annotated with named attribute, which would allow to match their values to the parameter of the Spaceflight News API constructor. And secondly, these properties are annotated with different environments. This means Different values will get registered in Gettit depending on the environment based on the value passed in the DI initializing method. Injectable package declares its own environment enum, which can be passed into the generated registrations, allowing granular Gettit configuration based on the application environment. Injectable is a very powerful tool with many ways of customizing registrations in Gettit, including specifying factory constructors, dispose methods, asynchronous injectables, providing different implementations of the same abstractions, and registering third-party types. Check out the docs to learn even more. Next, I would like to really briefly talk about localization. The implementation I chose, which doesn't use code generation, includes these translation classes. It's better than having translations in the map, which wouldn't help to detect if I made a mistake in the string key. And also, this allowed me to concatenate strings with passed parameters. However, having created these classes is too much manual work for my taste. I prefer to delegate this task to i69n package by Tomasz Zwiecina. Here I have it among dependencies. It allows me to declare all the translations in the YAML file with this special extension. Then it generates Dart classes out of those YAML files, keeping field names. Thanks to the delegate I showed previously, I can read the current translation class from the context. And this allows me to have build time checks of the correctness of the string key and supports placeholders and plurals. i69 in the package has more features, including Flutter hot reload. As usual, I recommend checking the docs. And finally, the last topic for today is testing. Currently, the application doesn't have any tests. Let me briefly add them. I added a new dev dependency, BDD widget test, by Alexander Lyushchenko, and a test folder. And here are my tests. Pretty unusual, isn't it? What you see here is a Gherkin language with which I described the app behavior that I'd like to test. Let's read one. Scenario articles list first loading succeeded. Given API is mocked to succeed, and I run the app, then I see space light news text, and I see this text and multiple this text. After I describe the article list feature behavior this way, the BDD widget test has generated widget tests. The test name matches the scenario name, and inside the test we have method calls that match the scenario steps. The package already provides an implementation of many basic steps like I see text, I tap text, I enter text, etc. And if I need a custom step like API is mocked to succeed here, it generates a Dart file with such a method, but it's my duty to provide the implementation. So here I touch a DO interceptor that will mock a successful response from the space light API. Usage of BDD widget test plugin allowed me to test all the implementation layers of my feature, starting from the UI all the way down to communication with backend. For advanced usage scenario, check out the docs on Pubtools. And we're done with the second half. We looked into managing assets with Flutter